Good afternoon, guys. I'm Chris and welcome back to this Wednesday's episode of Rift Amps. Right, here's another one for you, and I'm definitely just about to shoot myself in the foot with this because I think it's going to be an easy fix, which means it's definitely not. What have we got here? This is a VHT Special 6, and it's a really cool little amplifier. It's got a single 6v6 in the output stage and a single 12AX7 in the preamp. Simple volume and tone control. It's got a pull boost, 2 inputs, little champy, that sort of thing. Customer called me up. He said, could he bring it in for repair? What's it coming in for? Quite simply, the lights are on, but nobody is home. So, yeah, he dropped the amplifier into me. We fired it up, and indeed there was no output whatsoever, no hiss, no hum, apart from the standard hum that you hear from transformers when an amplifier is running. Tells you that the magnetizing current is working and running, but apart from that, absolutely nothing at all. And a bit of history on it, if I spin it around for you, whoops. He did say he's had a couple of issues with it in the past, and those issues are, first, it's got a high power and a low power mode switch, and he said for quite a long time the high power mode didn't work. Or did he say the lower power mode didn't work? One of them didn't work, but that seemed to have self-fixed itself, which is really interesting. So I'd like to get inside and have a look and investigate that anyway, see if we can work out why that may have been the case. He said he's revalved it because the 12AX7 lost its vacuum and went white. So we used the phrase it's gone to air, so the vacuum's escaped, or air's got in, whichever way you choose to look at it. But he did a whole new, replaced both of the valves, and still no output. I did some very, very basic checks while the customer's here. We plugged the amplifier on. Yes, the light turns on. Fuse has not blown. Did check the fuse in the IEC socket. And just did some very, very, very basic diagnostic checks and things. Visual inspection with the customer stood in front of me. I could see the 12AX7 was lighting up, but the heater filament for the 6v6 was not. That's our first clue. Gave the valve a little wobble and it started to light up. And sure enough, we started to get some hum and hiss from the amplifier. Give the valve a little wiggle again. Bear in mind, this is a brand new valve, and the heater dropped out again. The heater turned off and the output of the amplifier disappeared. So we're probably looking at pins 2 or 7 on the 6v6 socket, which are our heater pins. So that will be our first port of call when we get inside. We're going to make the assumption for the time being, and we know what people say about making assumptions, but we're going to assume that this valve is good, and it's not the valve itself, because he's already gone through and replaced it, and the issue has remained. But we'll keep that in the back of our mind just in case. So we'll get this thing apart, we'll have a look inside. Visual inspection, as always, you know the score by now. We will have, we'll inspect that socket. We're looking for bent pins. We are looking for cracked solder joints. We're looking for lack of solder. That could be a thing. And then we'll go through the rest of the amplifier, see if there's anything else going on. Hopefully then it'll be a quick find, a quick fix. We can then fire this thing up on the bench, give it a bench test, see where we're going on. But yes, the VHT Special 6, lights are on, but nobody's home. Right, Q&A time. First of all, thank you so much to everyone who sent lots of lovely, kind messages to me about wishing me well. Hope I get better. I had a hell of a summer cold, I tell you that. As I'm sure most of you worked out, I completely lost my voice, couldn't say a word, and I felt terrible. I still came into work most days, did some mornings, but I did leave. I had the shivers and the whole works going on, so I couldn't manage a whole day, but I did still come in and get some work done. And it did mean that I got to do that really cool ASMR silent vid, which most of you seem to enjoy. It was a bit tongue-in-cheek for all the trolls out there who love to moan about how much I talk and waffle on in these videos. But it is my vlog, and that's what I like to do. I like to talk to camera. I like to talk to you guys, explain what I'm doing, and just show you what's going on here in the workshop. So yeah, I mean, it's but yeah, it was a fun thing to do, and I hope you enjoyed it. So anyway, we've got loads to talk about, loads to catch up on, loads of things to work our way through. So I'm going to do a couple of VCQs, etc., as we usually do. And we will take it from there. So I've got my comments and questions here. We'll start with the, what are we going to start with? The Mallard amp. So I've still got some more updates on that for you guys. Keep an eye out for that either in this video or the next one. We'll see how we get on. Rob Titheridge says, a leaky mustard cap. That's a new one to me. Just shows even if you think can't be that, check it. That's exactly the problem that many people run into. They assume that parts can't fail, and therefore, and especially new parts as well, you know, they'll fit a new part and a problem may remain or a new issue may appear, and they think, well, it's a brand new part, it can't fail, and it shouldn't be faulty, and they end up going down completely the wrong diagnostic direction. Same with the older bits, you know, parts do fail eventually. It will happen, it's guaranteed. So I've learned over time just to, you know, cover your bases, check everything, see where you are. Don't assume that something's going to be good, and just, you know, follow your diagnostic workflow. Check everything. Just because it's an expensive part or a valuable part or it's a desirable part or whatever, if it's faulty, it's faulty. So yeah, I mean, that was, I mean, to be fair, mustards do seem to last longer than other caps, but that doesn't mean they won't fail. So again, you never well, you always check. That's what I'm trying to say. So yeah, good point, Rob. Thank you so much for commenting. Regular commenter Wes said, sorry, I'm still working on the Tremolux here, the one from Hawaii that we're doing all the work on. I've made good progress on this, actually. So you've seen me do the filter board. I also did the same process on the bias board. So you know my rules, that the power supply of an amplifier needs to be bulletproof. So we get both of those done and sorted. The internal of the chassis is quite mucky and dirty, and I'm trying to balance for the customer cost versus improvement. So there are some things I'd like to do, but it would just, you know, the labour involved puts the repair costs through the roof for what you might call marginal gains and improvements and things like that, where there are other jobs that simply need to be done if we want the amp to be reliable and usable and sound good, etc., etc. So it's always that kind of balancing act. You know, how much of the customer's money do you want to spend? How far do you go with something? What do you want to do? And you kind of have to just make a decision on some of that sometimes. So, but I'm working through. But my rule, as always, get your power supply right. So that's your high voltage rail, your B+ rail, your powers, your grounds, your heaters. Get all of that stuff good. Because then you've got a strong foundation to build off and work from. Anyway, Wes says, I really like the new Osmo Cam, Chris. Video and audio really do sound good. Yeah, it is an improvement and it is an upgrade, and it's something I'd wanted to do for a while, but as with any new piece of equipment, you've got to learn to use it, and the face tracking feature is, you know, helpful, especially when you're handhelding and you're walking around and you're filming and vlogging stuff. But I'm just learning it. You know, I'm learning new features and functions of it every day. I've barely scratched the surface on what this thing can do. But you're right, the image quality is great, the audio quality is great, and when Noisy Josh visits more often, we can do some really cool more stuff. I want to start doing some field trips, go out and seeing people in the field and filming stuff, and this whole setup will help me do stuff like that as well. So yeah, looking forward to it. Anyway, Wes says, I was wondering if you found out what was happening with the lack of tone control on the tremolo channel of the Mallard 18 watter, and was it related to the tremolo failure? No, I did say in the video that it was the ceramic disc cap hanging off the tone control on that channel that had failed. Replaced that and the tone control came back working fine. So you probably missed that, Wes, but I did explain what it was. Perhaps I didn't explain it in a properly detailed fashion. I do apologise, but yes, that was the issue. So yeah, brilliant, well done. So we're missing the back panel here. Customer didn't bring that with him. It looks like we've got a chassis screw here, one on top and the same on this side. God, these rubber feet are so grippy. I think we need the Lazy Susan, but I'm not going to get it. We're going to struggle on without. So let's do the side ones first. So one thing to always check is that if you've got different screw lengths, which in this case we don't, so it doesn't matter which way around they go. But some chassis you'll get different size mounts at different points, and of course you absolutely do not want to miss those up. When taking these things out, okay, come on. Oh, do you know what I haven't done? Speaker. Can I get to it from this side? No. Because, oh, I completely messed this one up. I didn't use my eyes, did I? There we go. We are out. Right, okay, so let's have a look at these transformers then. Dual camera mode. Here we go. So, output transformer, OBMD 486, so we assume that means it's got both a 4, 8 and 16 ohm tap on there. 16 ohm internal speaker socket there, and on the back, yep, 4, 8 and 16. And a foot switch there as well. 12AX7 JJ unit. There's a dot on that one. Ceramic socket. Those cable ties coming through those holes there. What are they holding on? Probably cables. Right, 12A, not 12AX7, 6V6. Oh, I can't do this one-handed. One moment. Can't click my fingers today. And there is the octal socket. All of those pins appear to be fine. None of them look bent or twisted or out of shape. We get a nicer image. There you go. No, it looks fine. Power transformer, 230 volt, 50 hertz. So we've got 275 volt winding and a 6.3 volt winding. Ningbo Chaobo Electronics Company Limited. Fantastic. Right, let's spin this thing over and round. And let's have a look then. Well, I already see one problem. Which is that resistor. What's going on there? Sorry. Something going on with that 470 ohm resistor. Is that our 6v6 cathode? Could be. Or is it a dropper? Okay, so we've got some filter caps. Actually, looking closer at that 6v6, doesn't look as bad as I'm making out. I think it's just some solder flux that's got on there. Don't think it's the resistor itself. Yeah, that's what it is. Okay, so let's have a look. Okay, so just having a quick look. We've got an IEC socket on the back there. You see we've got a separate safety earth here, again, marked with our sticker. Even though we've got an IEC socket, which is your disconnect device, the on-off switch, which is this one here, is switching both the live and the neutral. Yep. So fantastically well done. Fantastic. Now, makes you laugh, doesn't it? If, you know, a Chinese brand can do it properly, why can't many of these boutique builders, you know, who should know better? Right, but anyway, enough about that. I'll get off my high horse for a minute. Let's look at this 6v6 socket. It's down here. Can we zoom in and get a better view for you? There it is, right at the back. Is that better? Yes, right, we're in. Pointer stick. So we've got from our, so that'll be pin 2, pin 3, pin 4. No, hold on a minute. I can't find the keyway. Okay, it's that way. So we're going to say that's pin 1. Can you see what I'm pointing at? Pin 1, pin 2, so that's a heater pin there, pin 3, where is it? Pin 3, yeah, so that's our anode. Pin 4, that's our screen here, fed from its own separate 470 ohm resistor here. Pin 5 is our control grid, and that's a 5K6 resistor on there, coming all the way over from here. Oh yes, that's right, yeah, so that's our feed in. That's our grid leak, yep, cool. Okay, and then next to it, there's pin 6 there, which is used an anchor point, pin 7, and this will be our heater. 5, 6, 7, yeah, so we need to double check these connections, both those two heaters. On pins 2 and 7, and then we've got pins 8 and 1 tied together, which go off to our cathode resistor, that one that we pointed out earlier. Sorry, you're not on camera. Okay, so I think we might get away with just reflowing those joints. I'll demonstrate to you the problem first so you'll be able to see what's going on. Apart from that though, look. We look at the overall construction of this amplifier for what you might consider a budget practice amp. You know, eyelet board, reasonable quality components on there. They certainly, I mean, they really haven't cheaped out. That's the interesting thing here. They could have built this a lot cheaper than it has been built. And that's interesting. It would have been nice to see, I mean, for the price point of the amp, I'm being really nitpicky now, to be honest. Super nitpicky. Would have been nice to see, you know, a belt and socket here. Maybe, you know, a nicer lead dress, you know, because a lot of this is flapping in the breeze. But again, you know, I'm being a professional nitpicker at the moment, and yeah, I've seen amps that are 10 times the price of this built to a lower quality. So yeah, not cool, not bad. Let's give this thing some power and let's demonstrate this problem for you so you know what on earth I'm talking about, and we'll take it from there. I'll tell you what, some of the solder joints on this Tremolux are questionable is the fair way to put it. So, just working my way through. I mean, there's one here. I'm not going to show you because I can't be bothered to get the other camera out, but it's it looks like it was soldered in prehistoric times. Anyway, Verban Trem, new commenter to the channel, welcome mate, says, hey Chris, well timed, again still talking about the Mallard. I've just installed a post-phase inverter master volume on my 1974X. Are there any non-factory mods that I would recommend to that circuit? I would prefer to get this thing a bit sweeter in the overdrive like a matchless Spitfire. At the moment it's a bit gritty and fizzy. I mean, as far as 18 watt mods go, there are loads and loads of them. One that I've always had quite success with in fixing the, getting that overdrive to be a bit sweeter, and it only seems to do this on the 18 watt circuits. So we're talking, Watkins Dominator as the the genesis of those onwards. Is to split the cathodes on your two EL84s. So rather than having a shared cathode resistor, split them. So I can't remember what value it would be, but you rather than them sharing a cathode resistor, you give them their own individual resistor and cathode bypass cap. So whatever value is in there now, say it's 270 ohms. You give each of them double that value, so 470 ohms would be the E12 value. And in terms of the cathode bypass cap, the one that always works is you go for a huge cap, 220 microfarad or 250 microfarad if you can get them. Put one of those on each of the cathodes with their own cathode resistor, and it really does change the way those output valves respond and feel. It's a feel thing. When those amps overdrive. So try that. If you like it, great, stick with it. If not, stick it back to standard. But that's something, I don't actually do that on my own amps, on my own 18 watters, because I'm trying to achieve something slightly different with them. But if a customer says to me, this is the way I'd like it to, especially that edge of breakup tone, I'd like it to do this very particular thing. One trick I'll use is to split the cathodes and give them their own individual networks. Right, the amplifier is mounted on some wooden blocks, main supply connected. Let's turn this thing on. Oh, it is on. Amplifier is on high power mode, and as you can currently see, and I'll try and get you a good shot without ruining my other shots. Can you see the heater lighting up on that 6v6? There it is, right? You see the orange glow? That's what we're looking at there. Hopefully, maybe if I move, no, that's the best you're gonna get. So let's just wiggle the valve socket. There you go. Did you see it go out? Maybe if I close that curtain, you'll see it. You might see it better. Maybe if I turn the lights off as well. We're going to go real dark. Okay, hopefully the image is still usable. Where is that light coming from? Can you see now? Can you see? If I come in, move that valve again, see it comes back on. Shift the valve the other way and it turns off. So that's our problem. You see, on And off. There it is. So positioning of the valve in the socket is crucial. But we've inspected the pins on this side of the socket and they do look good. So we're just going to start with a simple solder reflow on those pins. And we will put some lights on and then we'll take it from there and see if we can get this thing fixed with no parts required. Mark Eagleton, we're talking about the Tremolux now, the filter board, the video that I did on Sunday, says, you have nice hands. I'm no talent scout, but a hand modelling side hustle seems like it wouldn't be out of the question for you. I'll take that as a compliment. I'm not sure if you're saying I should give up amp repair, but thanks, Mark. Guilty of questioning the strain relief on the filter caps, by the way. Yeah, I foresee it coming, but it's... now I've been doing YouTube long enough, I know when people are going to, stick certain comments in and start questioning stuff. Partly because they're curious, but partly because you do get a lot of internet experts who don't think on a deeper level. They just see something and immediately comment and don't. But before they start typing, they don't go, well, hold on a minute, what's he actually done there? Why is he doing that? Maybe I can work it out myself before making myself look like an idiot on the internet. So, yeah, anyway, Mark says, does the adhesive foam on the foam tape tear up the board if you remove it? I love the idea of no silicone. Yep, me too. But feel a little apprehensive about possibly tearing up the original filter board. Nothing to worry about there, Mark. Here's the foam tape. It's actually quite a low... what you might call low to medium tack on the tape. So it holds itself in place pretty well, but it does remove quite easily and it doesn't pull up any of the board material when you do remove it. As of course with any adhesive, you can use heat. Well, most adhesives, sorry, you can use heat to help break the bond, but no, it certainly doesn't damage the board material. I know because I've tested it over a long periods of time. Gaz Cow, long-standing channel member, says, I see you use 19 AWG for your connections. Which tinned copper wire do you use as your main ground bus wire? Not 19. I actually use two different types. They're right next to me here. I buy it from RS, as I buy lots of stuff from. So I've got the stuff I used in that video was 20 gauge. 20 gauge AWG, that's the thinner of the type that I use. It's easy to manipulate, easy for me to say. And I also use the 18 gauge as well, the slightly thicker stuff, which is the same gauge as the solid core that I use for my heaters as well. And I know some of you will ask, but what was I using to straighten the wire? And if I could find it, I'd show you. But it's three little rollers. Where have they gone? There you are. Sorry, these things. Whenever you're working with wire and you're wondering what tool to use or what set of tools to use, go look at jewellery making. Jewellery pliers and wire straighteners and stuff. The world of jewellery making has got all of that sorted. They worked all that stuff out many years ago, and that's where you get the best stuff. So, to straighten this wire, you can see it's pretty kinked. In fact, I'll put a kink in it now. And then these three, they just kind of clamp round. They've got these ridges in, as you can see, and you just hold it tight and you just pull it through, and you do a couple of runs. Tightens that all up and it straightens it all up beautifully. No need to twist it with a drill and hang it vertically to pull it straight. You just use the correct tool and it works perfectly. So yeah, I use 20 gauge and 22 gauge. No, sorry, 18 gauge and 20 gauge. God, I'm getting confused now. Pre-tinned bus wire. I buy it in a spool. I probably get through 2 or 3 spools a year. I'm sure there's cheaper options, but when you find something that works for you, Gaz, you just stick with it, whatever the price is, because you get the result that you want. So yeah, that's what I use. Great. Okay, both heater pins on the socket resoldered. So I removed all the old solder. Check the wires themselves, just make sure there's no corrosion on any of the strands or anything like that. All back together. Reflowed new solder. You can see the heater is glowing, and no matter how much I wobble that socket, wobble that valve, she stays alive. There we go. So we'll get this thing on the test bench now and do some voltage checks, measurements, carry on giving this thing a service, because customers paid for 2 hours of my time, and so far I've spent 35 minutes. So we've got some labour time to use up to get this thing spick and span. We'll check the bias, we'll check the preamp bias as well. It's always a good thing to do, make sure we're not pushing the 12AX7 too hard. Clean all the pots, sockets, jacks, tighten all the grounds, and go through it and just make sure that this thing is spickety span, or whatever phrase you want to use today. Quick update on a personal project of mine. So this is the original head shell for the Bassman 135, the one that was completely trashed and I rebuilt for last year's Christmas special. Now, if you remember, as part of that project, a very kind viewer donated to me another original 135 head shell that he had spare, and it was in much better condition, and that's the one that I used on the, well, that's the one that I put the original chassis back into for that particular amp. But I then sent this head shell off to our good friends up at Modulus, who glued it all back together, made a new baffle for it, re-Tolexed it, made it all look nice and pretty, etc. And it's been sat there. Now, one of the projects I've always wanted to do was to build an amp that Fender never made, which was a 100 watt black panel Bassman. They did the 50 watter, and then they moved on to the Silverface era of amplifiers, etc, etc, etc. So, and there never was a 100 watt black panel Bassman, and that's something I've always wanted to do. It's been on my to-do list for quite a long time now, and I think now is the time for me to get that done. So what I've done is, we know that the chassis is exactly the same size as standard twin reverb. So all I've done is bought myself one of those classic standard off the shelf twin reverb chassis. And as you can see, I'm doing this one-handed, it fits perfectly. Let me get that in there. You get the idea. So it fits perfectly, and you always want the perfect sizing for your head shell on a Fender style cabinet like this. Well, it's not even a Fender style, it is a Fender cabinet. You want 1/16 of an inch gap each side. All right, and that's, so if you're ever going to build a cabinet or have one make one for you, you build it to the chassis. So you get the chassis that you're working with, you measure it, and then you build your cabinet. So your opening in total is 1/8 of an inch wider, so you end up with 1/16 of an inch gap either side. But as this is a original Fender chassis, so cabinet, I had to double check that the reissue or the aftermarket reman, whatever you want to call them, twin reverb chassis that you can buy off the shelf do fit, and it does, as you can see, lovely fitment there. So this is going to be the chassis I'm using for this 100 watt black panel build, and I'm really looking forward to it. And because it's already got most of the holes that I need, in fact it's got more holes than I need. So we've got the 4 octal sockets here for our 4 6L6s that we're going to run. I can run a standard 100 watt twin reverb power transformer, same with a choke. I've got an output transformer already I'm only going to need 4 of the 6 preamp holes. So when I do my board design, I'm going to be able to optimize. Maybe I'll split the channels as far apart as possible. I've got all the holes I need on the front. Now, the original black panel Bassman didn't have mid controls. Well, for the 100 watter, I've got the holes on the chassis here, and I think having a mid control would be nice on both channels. So that's what I'm going to do. Obviously, no reverb and tremolo. We don't need any of that. So there are extra holes that the faceplate will just cover up. Yeah, but that's the plan. Now, my plan for this is to also try and do it on a bit of a budget, just for a bit of fun. So I've got, what have I got? I've got stuff. I've got enough stuff lying around from old projects and bits that I can harvest to put into this. But if I can do it just with bits lying around the workshop to save me some money, then that would be good. I know I've definitely got an output transformer and a choke. I've got a stand-up style transformer that I might have to take one of the end bells off to make it work as a drop through, but that's fine. But yeah, that's kind of the plan for this. So again, we'll make a board. The only thing I did want to do is I'm probably not going to have the filter caps under a doghouse. I'm going to try and put them on the main board because, I mean, in this chassis, you've got so much space. I mean, again, because we haven't got the reverb and tremolo circuits, we're going to have loads of real estate. So we can definitely try and squeeze everything on in the main board, try and optimize all of our lead dress, grounding schemes, etc., etc. Anyway, I've been waffling too much. I'll give you updates on this as I go on. It's going to be a bit of a part-time project for me, just while I get other things done as well. But I'm looking forward to it. We're really keen to hear it. But yeah, let's build an amp that Fender never made. Michael Smith, again, another regular commenter. Welcome back, Michael. He says, I like the idea of putting the normally underboard connections on top of the filter board. Yeah, me too. I've started doing it more and more often. Especially, it just makes things more easier to work on and service, right? Because then you don't have to remove the board to get to anything. But it also gives you extra measuring points and ease of access to stuff. So I do it more and more often now. But it also means that for someone who, when you don't have underboard connections, if the next tech who works on that amp who isn't as experienced can easily see where everything goes. So sometimes I do underboard, sometimes I do overboards. It entirely depends on the amp, the application, where my mindset is on any particular day. But yeah, it's something I'm doing more and more often. I do enjoy doing it, and it does give a nice finish. Uncle Daddy, welcome back, mate. Haven't seen you for a while. Says, nice job on the board. Cheers, mate. Will that foam tape work harden with heat and time? I mean, over decades, probably, yeah. But, that amp will have a recap again before that happens. So I probably wouldn't worry about it. And of course, there's also the foam tape in the top of the doghouse to hold those original caps in place. So don't worry about it. It's all good. It's fine. It's a much, much better solution, for me anyway, than silicone or hot glue. Next question was from Jem Tonkin 605. So much cleaning. Yeah, I'm afraid it's one of those jobs where if you're going to clean it, you better clean it properly. And you'll see I verified that there was no resistance. It was all open circuit between each point afterwards. Because if you get a conductive path, you're going to get a failure, right? You're a top one, Chris. Thanks, mate. Easily in my top 5 for amp techs. Well, as long as I'm not the worst one, I'll be happy. What solder do you use? I heard from Friedman that AIM or AIM is good for lead-free. I use them for my leaded/silver, but obviously can't sell that stuff. Advice would be appreciated. So I came across, like most people, I've been through many different types and brands and different formulas. And I settled on a German brand called Felder, who do a nice range of solders, and I use two of theirs. I'd use their lead-free, which I talked about on the channel before. That's the one I use for any of my amps that need to be built with lead-free solder, which is pretty much all of them. Even my amps that go to countries where leaded solder is okay, I still use lead-free solder on them. I keep them all the same, build them all to the same standard, keeps it easy, and then it's done, right? And the stuff I use, it's heartbreakingly expensive. It hurts so much having to buy it, and the reason it's so expensive is that it is so good. If you didn't know it was lead free, you wouldn't know it was lead free, right? It flows just like leaded solder. It smells the same, it finishes the same, it just works beautifully. But for that kind of quality, you do have to pay for it, and it's every time I have to reorder it, I cry a little bit inside. But cheap lead-free solder is awful. It's just the worst, and I completely understand why people hate using it. But when you buy the good stuff, and I mean the really good stuff, then it works great. And I also, from the same company, Felder, I do buy some of their leaded solder, which I can use on servicing and repairs. It's only on the manufacture of new amplifiers that I can't use it. So I do use a mix of both. So on this Tremolux, for example, I am using leaded solder. That's what the amp had originally. It means you don't have to remove all of the old solder, to the nth degree. You can mix in some of the new with some of the old, as in if there's a little trace left, it's okay. And it's fine. So yeah, I use Felder. I can't remember off the top of my head what the part number is, but if I just have it on a spreadsheet and I just plonk the number in and cry when I have to pay the bill. But yeah, there you go. Yeah, great question, thanks. Right, fired up on the bench. We are plugged into the 8-ohm output, so we are driving 8 ohms, and we're in the high power mode on the switch. We will test low power mode as well. I've currently got the tone on 0, volume on 0. We're driving the high input with a 150 millivolt RMS sine wave, 1 kilohertz frequency. Standard test numbers there. I've got the second camera up on the scope here, so I'll put that picture in picture, and that way you can see what's going on in detail. And we'll just advance the volume control at idle. It's pulling 31.5 watts out of the wall. Today's wall voltage is 240.9 volts AC, which means we are pulling 175 milliamps. So quite low power consumption from this amplifier. I think on the back panel it says, where am I looking? 33 watts of maximum power consumption, and we're pulling 31. So yeah, we are bang on, and I'm very happy with this. So let's advance the volume control. We will do the pull boost as well, see what happens. But here's our output sine wave. I think we've got quite a logarithmic pot on this, because most of it seems to be happening at the top end. Definitely squaring off there. We'll back it back down. Now, it's called the Special 6, so shall we make the assumption that it should be doing 6 watts clean? Now, 6 watts into 8 ohms would be 7 volts RMS on the output. We're currently at 6.2, so a little bit less than that. There's 7 volts there, so the way it works is voltage squared divided by resistance. So 7 times 7 is 49, divided by 8 gives you 6.1 watts. That's correct. So 6 watts there, 6.1 watts. We have got some rounding off, some squaring off, sorry, at the top, at the bottom. It's a single-ended amplifier, so we do get asymmetrical clipping, which you can see on the scope. That's pretty normal, nothing to worry about. Now, we don't know if what percentage of distortion, THD, total harmonic distortion, the manufacturer rated this amplifier at, whether they chose 2, 5 or 10%. Unfortunately, there is not a standard to which all manufacturers do rate their amplifiers. They should do it for low fidelity devices like this at 2%, but some choose 5, some choose 10, which obviously depending how much they want to fudge their output factor. So, but I would square it off there, back it down to where I would consider it to be a nice symmetrical sine wave, probably there. That's 6 volts output, so 6 times 6, 36 divided by 8, because that's 8 ohms, 4.5 watts, which for a single 6v6, perfect, bang on, happy with that. So let's try the tone control. I haven't looked at the schematic for this, but I would assume it is a standard high pass filter. And so we should get more output as we turn this thing up. As we do. So with our tone control at maximum, let's back the volume back down, see if we can still get the same clean power. There's our sine wave there, and we can get about roughly 6 volts output there, yeah, so that's fine. So we'll go back to, we'll put tone control halfway, bring our volume back up to where it seems to be happy, which was about our 6 volts, wasn't it? There we go. And let's, just in this position, we'll swap the, go from the high power position on the standby switch to the low power. So high power at the top, standby in the middle, low power mode there. You see we get a lower output there, and we're getting 1.6 volts AC output, which puts us about 0.3 to 0.5 of a watt, so about half a watt. If we bring the volume up to where it starts to round off, we might even need to zoom the scope in a bit more. There you go, that's a nicer resolution, definitely squared there, back to clean. So maximum clean power in low wattage mode, 3.3, so that's about somewhere between 1 and 1.5 watts output. So that's a nice step down, I think you'll agree. Back to high power mode, zoom the scope back out. All seems to be working very nicely indeed. The only other thing we need to check, it's got a pull boost mode on the volume control, so we'll bring that up, we'll pull that out, and we do get quite a big gain jump there. That's the switch in. I assume it's just a simple tone stack defeat. No, the tone control works, so we I assumed wrong. But there we go. So the amplifier is running quite nicely. The other thing we need to do, and we'll do some very quick bias measurements for this. Let me find a pen. Let me find a pen. Where's my pen gone? There it is. Where is my multimeter? It's around somewhere. Okay, so it's a cathode biased amplifier. So there's a couple of numbers, a couple of readings we need to take. So we will we'll check with no signal running through it, just in case we get some strange readings. First thing to do is we'll find our cathode resistor, which indeed was this one here. We'll measure across it, so voltage cathode to ground, 22.3 volts. Voltage cathode to ground. We also need to do voltage anode to cathode. So we can go that side there, and we need pin 3, which we worked out was this one. All in DC volts, 328. 328, and it was 22.5 volts, wasn't it? Just double check that. 22.5, correct. Okay, and the other thing we need to do is turn the amplifier off. Discharge the amplifier, because I need to measure the value of that resistor itself. That one there. Get the discharge cable on. There we go. We'll give it a couple of seconds to cool down. We'll measure the value of that resistor. And then with those 3 readings, we can get a basic bias number for the amplifier. Okay, 462 ohms, 462. So resistance of the cathode resistor, 462. Okay, can you see me? Can you see me? You can. So first thing we need to know is cathode current. So that's the amount of current flowing through that resistor. V equals IR. So current is voltage divided by resistance. So 22.5 volts divided by 462 gives us 48.7 milliamps. We always work in amps though, so 0.0487. Now our total anode plus screen dissipation, because both of those are combined for your cathode current, times that by our anode to cathode voltage, which was 328, puts us biased at 15.97 watts. That's a JJ6V6, so it's 15.97. Can you see that there? Yes, you can. It's 14 watts, plus we've got a little bit extra for the screen, but we always like to be a little bit conservative. So divide by your 14 means we are biased at 114%. 114%. So a little bit high. The next E12 value up from that resistor, for that resistor, 470 ohms, would be 560 ohms, which will probably bring us to cold, but it should be a 470 ohm resistor. It measures 462, so I might just put a brand new 470 ohm in there, which will cool the bias ever so slightly back up to where it should be, and I guarantee this amp is now going to run cool and fine without issue. So that's probably what I'm going to do, and then we'll leave this thing soak testing. I presume it's Sid Allen. Apologies if I get that wrong. Sid says, on the JM1 watt, why have you gone for off, up and on, down on the power switch? That's the way most people do it, isn't it? I mean, I'll put some examples on the screen now, but if you look at many amps, that's the way it's done. When you've, especially with main switches, you move a lever, you depress a lever into its lower position, that should be the on, as far as I'm aware. So other brands do it differently, but you know, that's the way I decided to do it on that. I could do it the other way round. Sometimes it depends if I'm hanging the chassis from the ceiling of the cabinet or whether it sits on the floor. I might do it differently, but yeah. You'll see from these examples on the screen now that many other people have done it that way, including the big brands. So it's down to manufacturer preference. Okay, final update on the VHT Special 6. New 470 ohm resistor installed. Don't worry, my finger's further away than it looks. I actually went through my stash and found one that was ever so slightly over spec, so 477 ohms it measures versus the 462 that was in there. Anode to cathode voltage has dropped slightly, 325. Cathode voltage has dropped, means the cathode current has dropped slightly, means we're down from 16 watts down to 15 watts and 107.5%. Bear in mind that does include your screen as well, so I think that's a much healthier position. It's fine, it's running great, and the amp is running fine, so it's all good now. Service has all been done, just need to reassemble it in the cabinet, and then we can call this one done. A nice easy fix. So just some dodgy solder joints on the heater pins of the socket and a quick bias adjust and service. Well, that's it then, guys. Thank you very much for watching once again. As always, please give this video a thumbs up, or your comments and questions down below. Subscribe and hit the notification bell if you haven't already. If you're feeling super generous and want to support the channel, you can join it like these guys have, and I will catch you all at the next one. going back to Michael's question, he also asked about racing and stuff like that. So he says, is the BMW in a different class than the Mazda? Yes, it will be. It's going to run in the class above. The classes are separated by they're power to weight formulas, so the BMW is a more powerful car, so it will run in the class above. I haven't done an update on racing in a while, so before we talk about the BMW, we'll go back to the Mazda and the last race, which was not the weekend just gone, the one before that. We went over to Snetterton in Norfolk for round 4 of the championship. Snetterton is my bogey circuit. I've never had a great result there. I've never been particularly fast around there, and unfortunately that trend continued. It's funny because, you know, I watch my footage and I'm driving the car as hard and as precise as I always do, but the lap time just doesn't come. And it's really frustrating because, especially when you come off the back, you know, the race before at Anglesey where I won and I was just on it and everything came together and you couldn't touch me that weekend. I was indestructible. In the next race, it's lots of little things that add up and it just doesn't come together. And the other guys were, you know, they way off in the distance, which was a shame. But I still finished third. And crucially, as long as the yellow BMW didn't win, it meant I would still be in with a chance of the championship. If they had won that race, then essentially the championship would have been over for me and there'd be no chance of me winning it. But I'm still in it because the little Vauxhall Nova won. Amazing drive. Good for them. In fact, the Nova's only 1 point behind me now in the championship. So, yeah, I'm not only am I looking ahead, I'm now starting to look behind as well. So, a bit of a shame, but you always get one bogey circuit, and the way the championship works is there's 6 rounds and there's dropped scores, so you always drop your worst result. And that third position is my worst finishing position of the year. I also finished third in the first race, but because there were less competitors in our class, I actually scored less points. So that one will be my drop score. So it's not as painful as I think it was, but it's pretty gutting when you put everything into it and the results just doesn't all come together, and it's very frustrating. But I'm still in the championship. next race is this weekend coming at Silverstone on the international circuit. So we run out of the Formula 1 pits. One of my favourite circuits, one that I've always gone well at but never actually won. I've finished second so many races on the trot by 1 or 2 seconds, so close to winning. Last year when I did that race, do you remember I broke down on the final corner of the final lap? So hopefully, fingers crossed, I get a good result this weekend. I'd love to win. I need a win for the championship, I really do. But I'd like to get a win there just because it's one of my favourite circuits. There are 3 layouts at Silverstone, going on a tangent here, and I want to win on all 3 layouts. And I've won on the national circuit, and I finished second on both the full Grand Prix track and the international. So I'm trying to do what I call the Triple Crown of Silverstone and get wins on all 3 layouts. So hopefully we'll see how it goes. I've got some new front tyres for the car this weekend. And for the low grip surface of Silverstone, that's always an advantage. My car always seems to go well around there. So fingers crossed it goes well. We'll see how it goes. Anyway, so that's the Mazda. We raced on the Saturday at Snetterton. On the Monday, as you saw in the last video, we took the B&W for its shakedown up at Bedford Autodrome, which is a test circuit. Lots of track days go on there. There's no racing there. Great test circuit. We did the evening session. Myself, Matthew, who races the yellow BMW that I race against, he came along to drive the car, help me. We needed to work out the damper settings for the suspension and also the brake bias, because it's got a brake bias adjuster, dial in exactly where that wants to be. This BMW is completely new to me. It's completely alien. I've got so much learning to do on it. So Matthew was a great help. We worked out where we wanted everything to be, where the car liked to be in terms of its suspension settings, tyre pressures, brake settings, stuff like that. The car ran for about 2 hours. My friend Nick, who I shared the Mazda with at Silverstone this year in a couple of races last year, he came to drive it as well, because he's going to race the BMW at Donington Park next month, middle of September. He's going to be racing the BMW for its race debut. I'm racing the Mazda to get some extra track time in. So we're going to run as a 2-car team. He drove the car as well. The car is just easy to drive. And what I mean by that is we all jumped in the car. You could just drive it pretty much on the limit from the get-go. Fine adjustments need to be made because it's a new car. It felt pretty similar to the Mazda. It has got power steering, but it is much heavier, but it didn't feel heavier. Got a nice bit of power. The engine is great. It just pulls all the way. Different limited slip differential in it. It's a clutch type or plated style LSD rather than the Torsen, which is a mechanical style in the Mazda. So the way you apply the throttle coming out of the corners is slightly different. But yeah, the car just pulled and pulled and pulled. By the time we were braking for the chicane, we were at 125 miles an hour, and it was still pulling strong in top gear. So yeah, that car be nice. Anyway, the whole point of a shakedown, and I know this sounds odd, but the whole point of going testing and to shake a car down is to break it. You're deliberately trying to break the car. You're trying to find the weak point, because you want that to happen then and not at a race weekend, right? And the car ran faultlessly for 2 hours. It was only a 2.5 hour session. The car ran faultlessly. We got the tyre pressures right, we got the brakes right, got the suspension right. And in my final session, I noticed there was a little bit of knocking from the passenger rear, the left rear of the car. We came in, we looked around, we couldn't see anything. We sent somebody else back out in the car. They said, oh, it's still doing it, it doesn't feel right. As the car came in, 2 of the left rear wheel bolts completely fell out. Completely fell out. Now, it uses wheel bolts on that car. There you go. rather than, you know, studs with nuts that hold the wheels on, like we have on the Mazda. And I'm not a fan of wheel bolts on race cars. Now, we did, after every run, we were retorquing the wheels up just to make sure they weren't coming loose. But, you know, vibration over curbs, stuff like that. 2 of them worked their way loose, and then the wheel was, which is no good. So I've done a stud and nut conversion on the car since then. So that's that issue sorted. So literally one of the wheels came off, which sounds ridiculous. But as I said, when you go testing, you're deliberately trying to break the car. Find out whatever the weakest point is on that car. You want it to show up and say, yep, I'm the weak point. So then you can fix it. So now that's that. What else does the car need before it races? And we're doing front disc and pads on it. I still need to do the gearbox and the diff oils to get those sorted out. I've got some more tyres coming for it, but it's pretty much ready to go. Just got to put my radio kit in it, and yeah, then we can race it. But yeah, we've proven the car can run. We fixed its weakest issue. It drives great, it runs great, and that car in Nick's hands should be on for a good result at Donington Park.